goodness, I'm not even on the right page with you guys. Hey, there we are. Hello, AP Calculus students. Mr. Ford here with a homework tutorial. This is 8.1.3, and I believe this will be the last homework that we do out of this packet. Kind of made the decision over the weekend to think, okay, let's do a circuit training that will really drive home the important points of three-dimensional revolutions, and we can be done with that. We can focus our attention on just some general AP test practice and reminders and points and hints. So that's what we'll do this week. So let's look at 828. We're going to sketch each region obtained by the boundaries below, contained by the boundaries below. Decide if you should use horizontal or vertical rectangles to calculate each area, and then set up and evaluate an integral to calculate the area, and then check the solution with a calculator. That's an awful lot to do for these problems, but you'll find that with the graphing calculator at your side, this will be very easy. So let's look at question A first. We're looking at the graph of, we're going to graph a bunch of stuff here, square root of x, negative x, x equals 1, which we can't graph on this calculator because it's a vertical line, and x equals 4. So if we think about this, I'm just going to do a zoom standard. You can at least kind of get an idea of what's going on here. We have a very, very small area right there, and we're going to come in and draw vertical lines at 1 and 4 also. So let's sketch that. Let's bring it over here. We do have to go negative a little bit on that, I see from the calculator. So we have our square root of x graph, which I'm going to go from 1, 2, 3, and 4 here. We do have we have a vertical line at 1. We have a vertical line at 4. Our square root graph, the square root of 1 is 1. 1, 2, 3, and 4. And the square root of 4 is 2. So the square root graph looks like this, kind of a curve like that on that area. And then the negative x is going to come through and do this thing where negative 1 to negative 4 down here is going to look kind of like that. I guess sketching it is half the battle in this case. Usually with these kind of problems, we want to think about, do we want to slice horizontally or vertical? This is a vertical slice for sure because the red function is always above the purple function. And we have some pretty clear boundaries from left to right. So the integral for this case, this is for question A, this would be the integral from 1 to 4. Our top function is the square root of x, and our bottom function is just negative x. And this would be in its own parentheses times dx. Now this is not terribly difficult to do by hand, so I suppose we'll do it this one for the practice there. Just remember that we are going to need to evaluate it at the end. So let's see here. I'm going to first of all think about the square root of x as x to the 1/2 power. So its antiderivative is x to the 3/2 power. And we're going to multiply that times 2 and divide it by 3, and that way the 3/2 will cancel out with the 2/3 when you take the derivative. For that is minus negative x. I'm just going to think about that as plus x there. And so I'm going to do plus x squared over 2. And I think that will do the trick, and we're just going to evaluate this from 4 to 1. It's not going to be super nice because we do actually have to plug a number in. Usually you get a 0 here or something. So we have 2 times 4 to the 3/2 power over 2 over 3 plus 4 squared over 2 minus 2 times 1 to the 3/2 power over 3 plus 1 squared over 2. And we're just going to kind of shake this out as best we can. 4 to the 3/2 power is the first thing I'm just going to kind of think about in my head. I know the 4 to the 1/2 power is 2, and then 2 to the 3rd power is 8, and 2 times 8 is 16. So this is 16/3 plus 16/2, and that first chunk. Over here we got 2/3 plus 1/2 over there. And so it might be a good idea to just combine together the parts you can combine. 16 minus 2 is going to give us 14/3. And then we have 16 minus 1, 15/2. I suppose we probably got to convert these two, don't we? 14 over 3 can be written as 28 over 6 by doubling everything. And if we triple everything in the second fraction, it's 45 over 6. And 28 plus 45 is going to be 65 plus 8, which is 73. 73 over 6, which I believe is the correct answer. It's not a super nice answer, but I mean, that's what it is. Yeah, 73 over 6. So question B, Very similar. This time we got x plus y equals 2, which you might want to write as y equals 2 minus x, just to make your calculator a little easier to deal with. And again, we have y or x equals negative y squared plus 4, which is, again, is not super fun. Negative y squared is equal to 4 minus x. We make this y squared equals x minus 4, and then when we take the square root, it's going to be plus and minus the square root of x minus 4, just to make it easy to graph. So I'm going to go to the calculator really quick. These kind of ones, you know, it is helpful sometimes to just think about it also. We have to do the square root of x minus 4 and also the square root of x, or sorry, negative square root of x minus 4. We'll graph all three of those. There's the straight line part. Let me bring calculator cam up to the front here. And there's that. They don't intersect at all. Did I do something wrong here? X equal to negative y squared plus 4. I did. Negative y squared is equal to... Oh, I had it right the first time. So I did a little bit of a math mistake there, as I am wont to do. This is x minus 4, so this is 4 minus x. So plus and minus the square root of 4 minus x. Got to go into my calculator and fix a little bit here. 4 minus x and 4 minus x. I'm going to graph that. There we go. This should work. We'll see how we do here. There we go. That's probably more what we're looking for. Ah, beautiful. Okay. So if we go to the sketch really quick, I'm just going to use another little space. Whoa. I'm going to use a little space right here to kind of, this is for problem B. Just kind of looking at what we got there. The first graph is just 2 minus x. 1, 2, 3, 4. 1, 2, 3, 4. So that is a straight line that goes through 2 and then has a slope of negative 1, so it looks something like this. Like that. And then the other one is this kind of plus and minus square root graph. I mean, it is just it's a parabola that's been turned on its side. So you could just think about xy pairs that work in the original equation, which I think was x equals negative y squared plus 4. Something like that. So you could, I mean, it's just a parabola on its side. So it has a vertex at 4, 0, and it intersects at 2, 0, 2. And then it intersects again, I think, at 3, negative 1. I think that's what it does. I am fairly certain that those points are correct. 0, 2 works for both, and 3, negative 1 works for both. I think that's important to point out. Yeah, 3 is equal to negative 1 plus 4. Okay, good. Now this one, vertical rectangles would not make any sense here because we'd have to change the integral once we got to this point right there. So we're not going to do that. We're going to use horizontal rectangles. We're going to slice horizontally, which means we've got to change things a little bit. We're going to make an integral from negative 1 to 2 because this time we're going up this way. And we're going to do that with our two functions. The one on top, the one furthest to the right, is the parabola function. So that is negative y squared plus 4 minus our line function, which was, well, it's x plus y equals 2 was the line. We're going to need the y equals version for this formula. So y is equal to, or no, we need the x equals version. So x is equal to 2 minus y, which I think is important there. So 2 minus y. And this is all times dy in this case there. Now, again, this one's not too terrible to put together by hand. I'm going to get a few steps in, but I'm probably just going to go to the calculator at the end because I don't think this is a thing you're required to do on your AP test, just a thing you should be aware of how to do. I think you should start by combining all the like terms. I see minus negative y there will be plus y, and you're going to have a 4 minus 2, which will be plus 2 right there times dy. And now you can just use the reverse power rule. This is negative y to the third over 3 plus y squared over 2 plus 2y, evaluated from 2 to negative 1. None of this is too terrible, but I also just want to get it done. So I'm going to go to the calculator and look at the integral from negative 1 to 2. You know, one thing that's tricky about calculators here is that you have to use, well, you can use y, as long as you put y in that little dy box there. I'm going to use x because I can. Negative x squared plus 4, close parentheses, minus, in parentheses, 2 minus x, close parentheses, dx, just like that. I think it should work. And we're going to get 4.5, which is the correct answer. If you want to keep going, you get 9 over 2. You'll have to just trust me on this one. 4.5 units squared, because it is an area, after all, on this problem. Okay, let's move on. We've been here for a while. We're not going to do 29 or 30, because ellipses are not a part of a thing we need to worry about. 31. Determine the value of h so that each of the functions below is continuous. This is a thing. We haven't talked about it in a while. It's one of the easier things you got to do on the AP test. All we're really going to do is we're going to kind of fill in the gap. Like for question A, which I'm going to rewrite over here, we have f of x equals, well, it's something. It's h if x equals 3. And it's x squared minus x minus 6 over x minus 3 if x isn't 3. So basically what we need to do is figure out how to fill the hole, because what's going to happen here is that this bottom function, this the guy right here, it's going to have a hole in it. In fact, what we should do right away is factor it. It'll be x minus 3 times something over x minus 3. And that is, let's see, if I factor x minus 3, it's going to be x plus 2 next to it. So just kind of factoring the top and then canceling them out. And that's what the function is if x isn't 3. The reason why it's not is because there's a hole at x equals 3, so it's going to be something else. What we're doing here is saying what we're going to fill the hole. Now, the cool thing is that if you actually go and plug in 3, you get 3 plus 2, which is 5. And so that's what the function actually is doing at that point. If you were to graph it, you would see a straight line, and at 3, 5, there would be a hole missing. So what we need to do here is say, okay, h has to equal 5. Because that will fill the gap that's missing there. H has to be 5. Because the function is going to give you 5, or it's going to look like 5 would plug it right in there. I guess if you were allowed to use a graphing calculator on this, you could graph the bottom function and see that point happening. But the idea is that that function has a hole at 3, but otherwise the value should be 5. The limit as you approach on both sides is 5. For question B, let's see if we can do this one here. This is, again, kind of your classic piecewise value function. We need these two things to equal each other when x is 3, because there's a jump when x is 3, and we need to make sure they equal each other. So here's the question we need to solve over here in question B. We need the square root of x plus h to be equal to negative x plus h, and specifically when x equals 3. Because these functions are perfectly continuous on their own everywhere else. It just so happens that we're going to jump from one function to the next, and we got to make sure we do that continuously without picking up our pencil. So we got to know what the y value is, what they have in common when x is 3. So that gives us this function to solve. Square root of 3 plus h is equal to negative 3 plus h. We got to solve that. We could stare at this for a while, I'm sure, and probably solve it, but we're going to square both sides, which gives us 3 plus h equals, be careful, negative 3 plus h squared. The most classic math mistake is that you cannot just distribute that squared. This is going to be 9 minus 6h plus h squared. And I think the best way to solve a quadratic like this is to gather everything onto one side and make it equal 0. So 0 is equal to h squared minus 7h plus 6. I think I've done that correctly. And now I'm just going to factor it. 0, let's see, because we can just make this minus 1 and minus 6. Like that. So what that means is that h could be 1 or h could be 6. I believe there's 2 answers for this. We could plug them in, I suppose. Oh, you know, it's going to look like there's 2 solutions, but one of them won't work. If we plug in 1, let's see, if we plug in 1... oh yeah, try it out. If h is 1, you get this. You get the square root of 4 equals negative 3 plus 1. This is 2 and this is negative 2. So even though it looks like it should work, it actually doesn't. That's called an extraneous solution. But if h equals 6, it totally works. You get the square root of 6 plus 3 plus 6, which is 9, and negative 3 plus 6, which is 3. You get 3 equals 3, so it totally works. So it's h is 6. That's what it's got to be. Pretty cool. Let's keep going. I'm probably going to have to make this a 2-parter. That's all right. 832, we got no calculator integrate. I have marked C and D with exclamation points because these are ridiculous things. You know, if you are really advanced in this class, if you're really vibing with everything that's happened, maybe you recognize what's happening in those problems, but we will talk about them, but I'm not going to require them, but they will be answered as part of this video. So for question A, with no calculator, and we have to integrate that. Well, I think it's probably going to be best to do a U substitution for this. Do I have any room off to the side, or did I use up all my room? I think I might have used it all up. Man, I'm using a lot of space for this assignment here. This is question A. We're looking at the integral from 0 to 1 of e to the x over 2 minus e to the x. 2 minus e to the x dx. I think, oh, and that's squared. I think this is a really good candidate for U substitution because I notice that the derivative of 2 minus e to the x would just be negative e to the x. So we can deal with that. Let's try that. Let's make u equal to 2 minus e to the x power, because then du is just going to be negative e to the x, because the 2 goes away when you take the derivative. And so negative du is equal, oh, there should be a dx on this. Negative du is equal to e to the x dx, and there's your substitution. You got e to the x dx right there. You got your u taken care of. So this becomes the integral, the negative integral, of 1 over u squared du. And then one last thing we got to do, we got to check our plugins here. Our bounds are going to be different. We u of 0 is thankfully 2 minus e to the 0, which is just 1. And u of 1 is not fun, 2 minus e. That's it. So our integral now goes from 1 to 2 minus e. That's not super fun, but we'll deal with it. So the antiderivative of 1 over u squared, that's u to the negative second power. Might be a good way to think about that. So the antiderivative there is going to be u to the negative first power over negative 1, but this is all negative also. So we might think about that. We do have to evaluate this too. So 2 minus e over 1. So let's think about this. This is the negative integral of, the first chunk would be, I suppose the more I think about that, that's negative 1 over u. So this is negative 1 over 2 minus e minus negative 1 over 1. And that's all negative there. Yeah. Yes. Shkwabbidi-doop-doop-doobity-doo. Okay. Well, to make this easier for ourselves, what we could do, negative. Let's get some common denominators going on here. Minus, let's multiply this by 2 minus e over 2 minus e. This is negative 2 minus e over 2 minus e. That's that. So now we can subtract. This is going to be, holy beans, this is the last problem here. Negative 1 plus 2 minus e. So negative 1 plus 2 will be 1. So it's going to be 1 minus e on top. Yeah. E. Yeah, this is e plus 1. I think I got that right. Yeah. Is the e negative? E is going to be, no, the e is going to be negative e plus 1. Because the negative e will be negative. There's enough negatives there. I'm just mumbling to myself. This is a good video. Good video. And don't forget we have that negative sign out in front. So it's going to become positive e minus 1 over 2 minus e. Okay. I like that answer. Yeah, that's what... Ah! Woof, that one got away from me. Look at that. It's not outside of anybody's reach. Just have to keep going. Keep plugging away. Question B. This is a pretty easy one. We can do it right here on the page because we're taking the derivative of an integral. That's usually a thing that you got to jump out at you. Derivatives of integrals are going to cancel each other out. The difference here is that we have to think about chain rules. So what we're going to do is we're going to plug an x squared in, first of all. So this is going to be just f of x squared. But we have to multiply by the derivative of x squared because of the chain rule, so times 2x. And then I suppose there's going to be a plus c on this one too. No, there won't be. That's just going to be it. So this is going to be 2x times f of x squared. That's it. Oh, I should have written it as f of x squared over there, not f of x squared. Oops, see, I almost did it again. Pretty cool. Okay, that's that one. For question C and for question D, okay, I am going to take the time in this video to explain these problems, and then that'll probably be the end of this first part here. Okay, so question C, you might not recognize it right away, but this is going to be a u substitution. U is the secant, because the derivative of secant is secant of x times tangent of x. Maybe that jumped out at you. Maybe you saw that pattern. Because now what we have is we have a pretty straightforward u substitution going on here. So what we're going to have is we have the integral of 1 over 1 plus u squared du. Now, I don't know if that vibes with you for a minute, but you might recognize this basic formula. That's one of our inverse trig functions. It's the inverse of tangent. That's the derivative of tangent inverse. So what you have here for an answer is the tangent inverse of u. That's what this derivative is. This is the tangent inverse of u plus c. This problem revolves around you recognizing the trigonometric relationship between secant, the derivative of secant, and secant tangent, and also seeing the tangent inverse going on there. I'm pretty sure you could probably do this problem with some trig identities also. So the final answer would be tangent inverse of the secant of x. That would be it, plus c. Similarly, question D also requires you to recognize one of our fun inverse trig formulas, and on top of that, it's got some other stuff going on. So this is just, I mean, you have to just kind of know this to do this problem. This is why I don't like this. You have to kind of know that the derivative of the the ddx of the sine inverse of x is equal to 1 over the square root of 1 minus x squared. Like that. Now, we don't quite have that going on here. We have kind of a u substitution thing happening here too, as if it wasn't tough enough. What we're going to do here is we're going to call u equal to x squared, and then du is equal to 2x, or in dx. And in this case, that means that 1/2 du is equal to x dx. And there's your u substitution. X dx is right there. And this right here is not quite a perfect 1-to-1, but that is u squared. So what you have here is you have the integral, you have 1/2 times the integral of 1 over the square root of 1 minus u squared du. And that, again, if you recognize that pattern, this is the antiderivative of the sine inverse of x. So again, this does require you to just know a lot of stuff, which is why we typically don't spend a lot of time on trig inverse unless you're really, really like bent on knowing everything in this class. But these rarely show up on AP either. They're worth knowing, I guess. They're worth being aware of. This is 1/2 times sine inverse. If we had more time this year, we would have spent more time on this. I'm just going to go ahead and plug in my u in there too. Sine inverse of x squared plus c. You can hear my third hour is arriving really quick, so let's try out question E. Actually, we might save question E for the next part of this video because it's going to take a little bit of time to think about. But yeah, we'll stop right there. So I will upload this video and I'll finish the rest probably during advisory today, and I'll see you guys in the next video.